and welcome to STEM Pursuits with Mr. Clausen. Today we are going to talk about dividing polynomials using synthetic division. So this is a little bit different from the lesson that I just talked about in the previous video. Specifically today we are going to talk about how to divide polynomials using synthetic division and then evaluating factors of a polynomial. So the video format's going to feel really similar to the previous video I just did on long division, but there's some really useful applications of synthetic division that I want to talk about and go through, because a lot of students find this technique really useful once they get the basic idea of how the format works. But we're also going to talk about a couple of the minor limitations that's involved. So the idea with synthetic division is that it does the same thing long division does, but it takes a lot of that writing component out of it that sometimes gets students lost and confused. So one of the things that you do with synthetic division is that you use the roots of the binomial that you're looking at to see if it is a factor, so binomial. And when we're going through a specific problem like this, what we want to do is we want to find the root. So the root is the value that makes it equal to 0. So if x is equal to 2, then the binomial is equal to 0. Okay, so you're always going to take the value that makes the binomial equal to 0. So what we're going to do is we're going to use that value and we're going to plug that in front of the polynomial. And then what we're going to do is that in the synthetic division bar here, they do this little thing. We're going to put the cubic terms in front. We're always going to start with the highest power term first, the quadratic, the linear, and the constant. And what I'm going to do is, instead of putting this whole polynomial in here, we're just going to use the coefficients. So coefficient to x cubed, 1. Coefficient to x squared, -4. Coefficient to the linear term, 6. Coefficient for the constant, -4. Okay, so now this is all we're going to use here. We're going to use 2, and then we're going to have this random array of numbers. So what you do is that whenever you're looking at this, you're just going, all right, like the only situation that you can use synthetic division for is if you have this 1x scenario here. So what we're going to do is we're just going to say, all right, if we multiply x squared with x, like we're just going to go look at this here, and we're just going to drop this down, and we're just going to say 1. And we're going to drop that down because you always just multiply x by the power of the coefficient that is already there, the x squared. And because x squared times x will always get you x cubed. And the reason that you take the root is it kind of applies that minus sign to it already as you're going through it. But then what you do is that you always take this number and then you multiply it by this value here. So we're going to go, and we're just going to drop it, and we're going to go 1 times 2. And then we're going to put 2 here. And then what you always do is you go -4 plus whatever terms here, and then we'll get -2. And then we'll go -2 times 2, and we'll get -4. And 6 minus 4 is 2. And we'll go 2 times 2. Okay, it's just the value that I have here. And we'll go 2 times 2 is 4. And -4 plus 4 is 0. Okay, and then we get these new set of values down here. All right, we get this new set of values, which is really what we're interested in. Because now what happens is that since you're dividing each of these terms' coefficient by x, what this translates to is a new polynomial or trinomial that is just 1 power less than what's up here. So what does that look like? Well, x cubed divided by x gives you x squared, x, constant, and then this part here is the remainder. Okay, so what this allows you to do is you can just say x squared minus 2x plus 2 is the binomial that crashes out when you divide x cubed minus 4x squared plus 6x minus 4, and we divide it by x minus 2. And the remainder for this polynomial is simply 0. And you just did that same process that you could have done with long division, and you got it with this technique. So it does have some flaws, but if you get used to the format, I find that my students really like this technique because they just line up all the coefficients. They're just doing simple multiplication going through it instead of having to think about like the polynomials the entire time. So if you get the form and just work through it, it actually is a really fast way to solve a given problem. With that said, let's look at a second example. So again, my root here, the root or the 0 is x equals negative 2. Previous example, it was positive 2. Okay, so this is my root. And so I'm going to plug negative 2 out front. And what I'm going to do is, all right, I'm going to plug my x cubed term down here. You don't have to write these above. Okay, but I'm just doing this just for the sake of keeping track. So my coefficient with x cubed is negative 2. Coefficient with x squared is 5. Negative 1 with x. 2 with the constant. Now, what I'm going to do is, the first thing you always do is you just drop the negative 2 down here, and then you multiply that by the term that's here. So, negative 2 times negative 2. Okay, that's going to give you 4. It's going to give me 9. Okay, now, with this situation, I'm going to go now 9 times negative 2. It's going to give me negative 18. Negative 18 minus 1, negative 19. And I go negative 19 times negative 2. It's going to give me 38. Right? I'm going to do all that math, and I get 40. So what this means is now, if I was to actually go and factor all of this out, again, remember that everything's just 1 power less. So this will mean negative 2x squared, because this was x cubed and it turns to x squared and it turns to x, so plus 9x. And now we go x, which this will mean this is the constant, 19. And then we have, we have a remainder here. So now we're going to say a remainder of 40. Okay, and this would be your answer. And if you're like, well, what does this actually mean? Well, what it actually means is that if you were going to write this out, you would have to say that you would have to go x plus 2, and you multiplied by negative 2x squared plus 9x minus 19, that you would have to add 40 to that answer once it's all said and done in order for it to be equal to this polynomial once again. So when you're going through, it's just a useful technique. It's just a different technique, and if you have a simple binomial that you're trying to factor out, it works really good. Now with that said, if you have a 3x situation here, you cannot use synthetic division. So if you have a more complicated binomial, and all I mean is that your highest power term associated here has to be a 1 here. So you can have x minus 2, x plus 5, x minus 19. You can have any of those, but as soon as you start doing like x squared plus 1, or 3x minus 2, or x cubed plus 2, none of these work. Not allowed. But all of these are okay in that type of situation. So in this specific scenario, long division is your only method. Okay, so you do have to know both, but if you like synthetic division, hey, just go for it. And it is faster to use. So again, if we want to evaluate a factor of a polynomial, just like we did in the previous video, again, remember the root is -2. All you're trying to do is find the 0 of the actual polynomial. Go -2, plug it through, 1, 4, 1, -6. And I'll just show you how fast this actually is. -2, 2, -4, 3, -3, 6, 0. And now I look at those numbers and I get x squared plus 2x minus 3 with a remainder of 0. And that's literally how quick this entire process can be using synthetic division. So once you get the mechanic of it, of the process, it's actually very fast and a very efficient method for checking for factors, roots, those type of things. Again, as long as the binomial is really simple. And yeah, I hope that you found this video helpful in ensuring your understanding of synthetic division and that you have a great rest of your day.